Hello everyone. Last time we have done a chapter which is called carbonyl compound in one shot. Today we are going to cover acid and base. So let's start with the acid base. This is one of the most important chapter in organic chemistry. Okay. So here we have some concept. The very first one we are going to talk about the Bronsted acid. Which one? Bronsted acid and base. So first of all we should know what is Bronsted acid. So let me explain this. So Bronsted acid is basically proton donor. And what is Bronsted base? Proton acceptor. Okay, proton acceptor. So in this case you can see we have oxygen have a lone pair and this is HCl. So you can see HCl becomes Cl minus. So there is a loss of proton from HCl to Cl minus. So this HCl is a proton donor. So this is a Bronsted acid. And if you look at water and H3O ion, this is hydronium ion. So there is a proton acceptor. H2 is going to grab a proton. So this is a Bronsted base. Clear? This is a Bronsted base. Suppose I have an example. We have, suppose this one. Here we have ammonia and this is HCl. It gives you NH4 plus and Cl minus. Let me know which one is my Bronsted acid and which one is a Bronsted base. So please compare this. We all knew NH3 to ammonium ion. This is a proton acceptor. It grabs the proton because in ammonia you have 3 hydrogen and here you have 4. So there is a addition of proton. So this is a proton acceptor. Proton acceptor. Proton acceptor, which means Bronsted base. Bronsted base. And in HCl, this is a proton donor. Proton donor. So what is this? This is a Bronsted acid. Okay, Bronsted acid. Makes sense? Now the next is, again we have this example. Okay, Lewis acid and base. So what is Lewis acid? So Lewis acid is basically electron deficient species. We can say electron deficient. So it can accept the electron. So we can say this is electron pair acceptor, also called as electrophile. Electrophile. Clear? While Lewis base is what? This is electron rich, electron pair donor. Clear? And nucleophile as well. Nucleophile. So we can discuss example here. We have H2O. We have H2O. And here we have HCl. And it becomes H3O plus Cl minus. So look at here. Oxygen has lone pair. So it donates its lone pair to this H because HCl is like this and H2O is in this way. Clear? So in this case you can see this is electron pair donor. So this is electron pair donor. It means what it should be? It should be Lewis base. And this HCl is a electron pair acceptor and that's why this is Lewis acid. Clear? Because we all knew HCl break down into H plus Cl minus. So this lone pair can give its electron pair to the proton. Make sense? So proton. So this is the electron pair acceptor H plus. The H plus is a part of HCl. That's why HCl is the electron pair acceptor. Suppose you have this one. Boron has a vacant orbital. So ammonia has a lone pair. It will donate its electron to boron. So this is an electron pair donor. So this one is a Lewis base and this is an electron pair acceptor. So Lewis acid. Clear? Now the next is conjugate acid and base. I am going to discuss here. Look at conjugate acid. What is conjugate acid? It is formed by the addition of proton. We can write here it is formed by the addition of proton. Clear? In this way. Suppose you have H2O molecule. If you are going to add a proton here, so you can see here you have 2 hydrogens, so here we have H3O. Now this is a neutral, H2O is a neutral here and you have a positive charge. Clear? So you still have a positive in the product. Make sense? Suppose here you have OH minus and we are going to make its conjugate acid. So again H plus. So now in this case you have just 1 hydrogen here. So once you add a proton it will become H2O. But what should be the charge here? There is a no charge. Why? Because 1 negative and 1 positive is cancel out. Clear? So these two are the conjugate acid. Suppose we have this one SO4 minus 2 and we have to draw its conjugate acid. So I said that we have to add a proton, 1 H plus. So if you are going to add a H plus, it will become HSO4. But what should be the charge here? Look at. It has 2 negative and 1 positive. So 1 plus minus cancel out. But still there is a 1 negative. So this is my conjugate acid. Make sense? Now the next is conjugate base. Conjugate base. So it is formed by the removal of proton. Removal of proton. Suppose you have HCl. If you remove a proton from HCl, you know, HCl is like this. So if you break this bond, it will be plus, it will be minus in this way. So once you eliminate H plus, there will be Cl minus. So this is a conjugate base. So simple thing is that if you have a neutral species and you are going to eliminate a proton, then there will be 1 negative in the conjugate base. 1 negative whenever it is neutral. Clear? Suppose it has a positive charge like this. Suppose you have H3O plus and we are going to form its conjugate base. So H3O plus at this moment. So once you are going to eliminate a proton, it will become H2O. But I said that it is already a positive. Clear? It is already a positive. So once you are going to eliminate H plus, so 1 positive, 1 negative cancel out and there is a no charge here. Look at here in this case. Look at this example. Suppose we have this molecule structure in this way. Clear? This is the H3O plus. If you are going to break a hydrogen, so I said that this is plus, this is minus. So 1 plus 1 minus cancel out, that's why net charge is 0. What is a conjugate base here? HSO4 negative suppose we have, and what should be conjugate base? So again you have to eliminate a proton. So SO4, and I said that elimination of a proton can form a negative charge in a conjugate base. it already has a negative, one more negative, so there is a -2. Clear? So this is the story of conjugate base. And one more thing I want to add here, acid forms conjugate base by removal of proton, and base forms conjugate acid by addition of proton. Clear? Minus means elimination, plus means addition. Make sense? And one more thing I want to add here. One more thing. Strong acid have weak conjugate base, and weak acid have strong conjugate base, and strong base have weak conjugate acid, weak conjugate acid, weak conjugate acid, and weak base have strong conjugate acid. Clear? So this is very, very important. What is conjugate base? Once you are going to eliminate a proton from a species, that forms a conjugate base. And what is conjugate acid? It is formed by the addition of proton. Okay, so you can see this is about the conjugate acid and base. Makes sense? Okay, let's talk about these type of equation. Suppose you have this one. Now we have to mark here which one is a conjugate acid, which one is a conjugate base, which one is a acid, and which one is a base. So let's compare ammonia with the ammonium ion. So you can see in the product side we have an extra proton. So this means this is a conjugate acid, and I said that conjugate acid is formed from base by addition of a proton. So this is a base, and here you have addition of proton. Now the next is HCl to Cl minus. There is a loss of proton. Clear? Because this is HCl and this one is a Cl minus. So this is a conjugate base, and this is what? Acid. So if my question is how many acid pair we have, sorry, which one is my acid here? So these two are the acid, this and this. HCl and NH4 plus. Which one is my base? Ammonia and Cl minus. Makes sense? So this is the conjugate acid base. We have done this already. Okay, now the pH scale. Look at here. This is a neutral. This is 8, 9, 10, 11, 12, 13, and this is 14. Here 6, 5, 4, 3, 2, and 1. So left to the 7, this is called acid, and right to the 7, this one is my base. 1 to 2 is strong acid. 3 to 6 is a weak acid, 8 to 11 is my weak base, and 12 to 14 is a strong base. Clear? Now there is a one more information. The formula of pH is equal to minus log H plus, and pOH is equal to minus log OHN. So one thing we can say here, H plus and pH is inversely proportional. Okay, so pH is inversely proportional to H plus. Why? Because this is minus log form. Clear? So higher the HN, lower the pH. Clear? So now the next is, suppose you have a acid HA. If it is going to dissociate, it forms H plus and A minus. And if you are going to write down the K, the ionization constant of acid, it is a concentration of product divided by reactant. So you can see Ka directly proportional to H plus. So higher the concentration of H plus, greater the Ka value, higher the concentration of H plus, greater the Ka value, higher the H plus, higher the acidic strength, okay? And higher the acidic strength, it means pH should be low. And if Ka is my high, then pKa should be low. Clear? Because pKa and Ka have inverse relation. Makes sense? Because formula of pKa is minus log Ka. I hope it makes sense. This is quite simple relationship. Now the next is base. Suppose you have a BOH, any hypothetical base, it dissociate to give you B plus and OH minus. And if you are going to write down the Kb for this, it is a concentration of B plus and OH ion divided by BOH. So from here it is very clear Kb directly proportional to OH ion. So higher the Kb, greater the OH ion. Greater the OH man means basic strength is high, and high Kb it means pKb should be low. Clear? And higher the basic strength, greater the pH. So higher the pH, more will be the basic. Makes sense? So these relationships are very, very important. Now the next thing is, you can see they all have such information. We have done this already. This is about the base. Okay, now the next is very, very important, cardio. You know, C for charge, A for atom, R for resonance, D for dipole induction, O for atomic orbital, okay? So if you have to compare the acidic strength of any compound, then we can use this application, this formula even you can say, the cardio. So let's start one by one. The very first one is a charge one. So quite simple thing, acidic strength of positive charge is higher than the neutral and then negative. Clear? This is why this relationship, because positive charge is a deficiency of electron, and we all knew deficiency means electronegativity. So if you have a electronegative element, that means that is a more acidic. So you can see, if you are going to compare the acidic strength order, H3O plus has more acidic because positive charge, then this is neutral and this is negatively charged. Negative means electron rich. Positive means electron deficient. And this is a lone pair one, neither the rich and the deficient. This is quite okay if you are going to compare with them. Here as well you can see the acidic strength increases if you are moving left to right in this compound, because it is positive and this is a negative charge. And look at the pKa value. Lower the pKa, higher the Ka and higher the acidic strength. So you can see this one is a 9.2, lowest pK if you compare. That's why most acidic is NH4 plus, ammonium ion. Now the next is atom. In the periodic table, we all knew if you are moving left to right, electronegativity increases and acidic strength also increases. That's why fluorine is more acidic than oxygen, than nitrogen, than carbon, because this is fluorine, here oxygen, here nitrogen, and here we have carbon. Makes sense? So this is acidic strength, lower the pK, higher the acidic strength. So left to right, as you're moving left to right, the electronegativity increases and acidic strength increases. Now the next, I think the size one next is, yes, this one. So this is top to bottom movement. We can say here on moving top to bottom, size increases and acidic strength also increases. Okay. So if you compare iodine and Hi, HBr, HCl and HF, this is iodine, this is bromine, here chlorine, and here we have fluorine. So iodine has the biggest size, so that's why more acidic. Makes sense? Suppose you have to compare H2O and H2S. Let me know which one is more acidic. So you know here we have oxygen and here we have sulfur. If you look at the position in the periodic table, here oxygen and here sulfur. So down the group, size increases. Size increases means acidic strength increases. So H2O is a strong acid, H2S. Now the next, the resonance one, the resonance. Okay, so first of all, you should know what is resonance. So I am going to teach you here the negative charge resonance case. So look at here. Whenever charge, any charge, positive or negative, is in alternate with the double bond, alternate with double bond. This is the condition of resonance, okay. Look at the example. So you can see here we have a double bond and this is a negative charge. This is an alternate. Alternate means charge and double bond is separated by a single bond. Clear? This is a story of resonance or delocalization or conjugation. So you can see double bond and charge, we have a single bond. Double bond and charge, we have a single bond. So this is all about the resonance. Clear? Now look at the acidic strength with the resonance. Suppose we have two acid, one is CH3CH2OH and one is this one, CH2 double bond CHOH. If you have to compare the acidic strength of the given acid A and B, first job is to eliminate the proton from the given acid and draw the conjugate base. So break this one. We all knew this is H plus, so O minus, so it will form CH3 CH2 O minus, and here we have CH2 double bond CH O minus, and here H plus and H plus. So this is my conjugate base, this is conjugate base. This is supposed to be second, this is first. Now tell me which one is in the resonance, which conjugate base is in the resonance. Take your time. I said that whenever charge in the alternate with the double bond, that is the story of resonance. And here you can see this negative charge, this negative charge is alternate with the double bond. Can you see this? Negative charge is alternate with the double bond. So this is in resonance. Here we have no resonance. Clear? So whenever any conjugate base is in resonance, that means this is the stable anion. So is stable the anion is stronger the acid. I can write here is stable the anion. I said that is stable the anion. Stable the anion is stronger the acid. This is a strong acid, okay. A lot of question can be from this theory part. Look at this one. Suppose we have this cyclohexanol and we have a phenol. This is called phenol. And my question is, which one is more acidic? So again, you have to eliminate the proton. So it will form this negative. And here we have this one. So this is in the resonance. Clear? The stable one. So that's why this phenol is more acidic. More acidic. So simple thing is that stable the conjugate base is stronger the acid. And stable conjugate base means the resonance. You can see here we have the alcohol and this ring. So once you eliminate the proton, here negative, this is in resonance, alternate. So that's why this acid is a strong acid. Clear? Same thing here. Okay, now the next is dipole induction. And I'm going to explain this according to my way. So dipole induction. Dipole induction is of two types. One is electron donating group and one is electron withdrawing group. So electron withdrawing group is directly proportional to acidic strength and electron donating group is directly proportional to basic strength. Clear? So what is donating group? Donating group are generally alkyl group. Alkyl group means a methyl like this, methyl, ethyl, these ones, and propyl, carbon containing hydrocarbons. And second thing is that if any species has a negative charge like this, suppose O minus, NH minus, CH2 minus, they all behave as a donor. Okay, so this is the electron donating group. Now what is electron withdrawing? Electronegative element like fluorine, oxygen, nitrogen, carbon, multiple bond containing functional group, multiple bond like C double bond OH, C double bond COH like this, carboxylic, NO2 group, cyanide group. So if you have a double bond, triple bond containing functional group, it acts as a withdrawing one. Let me give you an example. Suppose we have this one, CH3, CH2, COH. And here you have CH3, CH, fluorine, COH. And here you have CH2, fluorine, CH2, COOH. We have to compare the acidic strength of the given compound. So first of all, you have to categorize the electron withdrawing and donating group. We all knew electronegative element act as a withdrawing one. So you can see this fluorine is a electron withdrawing. Here there is a donor group. So first is the least acidic, first is the least one. Now this fluorine, this is also fluorine. So dipole induction is a distance dependent effect. Okay, so if it is close to the carboxylic or any group where we are going to compare, so if it is close to that position, that means a stronger effect. So this fluorine is a close to this carboxylic group, so that's why this has a stronger effect. So second is the most acidic and then the third one because it is far from the carboxylic. Clear? So this is called dipole induction. So you can see here, this is a donor group. Okay, you can see this is a lone pair you have. So lone pair means donor. So once you eliminate this, there is a negative charge, conjugate base. So it is a donor one. That's why this is a less acidic. As you can see, this is electron withdrawing NO2 and fluorine, and this methyl is electron donating one. Here we have some electron withdrawing group. As you can see, I already told you double bond, triple bond containing functional group. So NO2 has double, sulfonic has double, cyanide has triple, this is double, this is double, this is double, double here as well, and electronegative element like fluorine, chlorine, bromine and iodine. Clear? So they all act as a withdrawing. This is a donating one. I told you alkyl and having a lone pair and negative charge. There is a negative as well. So negative can also donate. I told you that basicity directly proportional to donating one. So this is a more basic. If you have, suppose here you have OCS3 and you have only this. And my question is which one is more basic? So this one is more basic. Why? Because there is a donor group. Okay, have a lone pair oxygen. Next is orbital hybridization. Look at here. This is my nucleus, okay? This is the nucleus. The very first is my S, after that P, next is D, and then F. So higher the percentage S character, more will be electronegativity, and more electronegativity means more acidic. More acidic. That's why carbon triple bond carbon is more acidic than double bond than single bond. Why? Because triple bond is sp hybridized. This is sp2 and this is sp3. And electronegativity of sp is more than sp2, then sp3, then sp3. Why? Because, take your time, just look at this. Sp has more percent S character. Okay, let me tell you what is percent S. Suppose here we have sp hybridized and I am going to figure out percent S. So it means the number of S orbital, which is 1, divide by total, which is 1 and 1, 2 into 100. So you have 50% S in sp. Next is sp2. Number of S is 1, total 3 into 100, which is 33.33. And the next is sp3, which is 1 upon 4 into 100, which is 25%. So higher the percent S, greater the acidic strength, because most electronegative. You can see sp hybridized atom is more acidic. Sp hybridized atom is more acidic than sp2 and then sp3. Clear? Because triple bond is sp hybridized, triple bond is sp, double bond is sp2 and single is sp3. Makes sense? So this is all about yes, clear? So this is all about the acid and base. If you have still any doubt, you can mail me, you can inbox me, you can message me on a Facebook. I'll clear your doubt. Thank you so much for watching this. Please share and subscribe this channel, okay? Thank you so much.